The organization of entities, whether physical objects or abstract concepts, constitutes a fundamental intellectual activity. It is a logical process of identifying similarities and distinguishing differences to establish order within a perceived universe of data. This method of sorting traces back to Aristotle, who formalized the process of separating an object's essence from its accident. By isolating what a thing truly is from its incidental qualities, we create the foundations of categorical logic. In information science, this logic relies on three units: the entity, which is the object being perceived, the characteristic, which is the attribute used as the basis for grouping, and the class, which is the resulting systematic order. Every act of grouping requires a corresponding act of division. Admitting an entity into a specific class mathematically dictates its separation from the remainder of the universe. Classification provides the coordination and control that transforms a chaotic mob into a disciplined organization. This relational mapping is the prerequisite for sharpness in thinking and clarity within any large dataset. Knowledge classification is inherently multidimensional. It functions as a conceptual map where theoretical frameworks and methodologies relate across numerous axes simultaneously. Physical storage systems, however, are restricted by the rigid, one-dimensional limits of linear shelving. A tangible object can only occupy a single spot in a sequence. The history of organization is a long-standing quest to map the infinite dimensions of human knowledge into systems capable of practical retrieval. Modern high-dimensional computational taxonomies represent the current peak of this effort, utilizing ancient logical principles to navigate the scale of digital information. The foundations of structural taxonomy reside in Aristotelian logic. His work established a hierarchical structure, prioritizing an entity's specific properties over simple binary division. This deductive method is illustrated by the tree of Porphyry. It starts with a broad genus, progressively divided into specific species based on distinguishing characteristics. A systematic notation is then attached to these classes, preserving the logical order for efficient handling. During the Renaissance, Francis Bacon shifted this objective logic toward human psychology. He proposed that all knowledge is derived from three primary mental faculties: memory, imagination, and reason. Thomas Jefferson later adopted Bacon's psychological faculties to structure his personal library, dividing his collection into the empirical chapters of history, philosophy, and fine arts. Jefferson's arrangement formed the literal nucleus of the Library of Congress, providing the structural logic for the primary research collection of the United States. Physical library architectures reflect a deliberate mapping of Renaissance psychology into structural organization. Bibliographic classification must translate the multidimensionality of knowledge into a filial sequence, a single file arrangement dictated by physical shelves. This imposes a one-item, one-place rule. Placing a physical book under a single class number denotes its primary subject, but physically separates it from all other related conceptual dimensions. To manage large collections within these 1D limits, libraries adopted enumerative systems, like the Dewey Decimal Classification and the Library of Congress classification. Dewey used 10 main classes and Arabic numerals to build hierarchies, while the Library of Congress utilized alphanumeric codes to provide greater specificity for massive research volumes. These linear rules were historically executed through mechanical index systems, the card catalogs that allowed users to navigate the physical constraints of the stacks. For centuries, the predictability of a one-dimensional storage sequence was the necessary trade-off for efficient retrieval. Information architecture in the digital era is no longer coupled to physical shelving, allowing for more complex organizational models. Digital metadata functions as a structured coordinate matrix. It allows a single entity to exist in multiple coordinate spaces simultaneously, enabling unprecedented search visibility. This chart details 4 types of professional metadata. Descriptive metadata identifies aboutness for discovery. Administrative metadata manages resource control and access policies. Structural metadata maps database schemas and API endpoints. Technical metadata documents required infrastructure like file formats. SR. Ranganathan's colon classification anticipated this digital flexibility. His faceted system demonstrated that deconstructing subjects into atomic parts allowed for infinite synthetic categorization. Metadata and faceted logic solved the dimensionality problem, allowing algorithms to retrieve data based on its conceptual meaning rather than its physical location. Machine learning has scaled these principles through automated text classification, where algorithms assign documents to categories by processing their content. This diagram illustrates the vector space model. AI models represent documents geometrically, plotting files as vectors in a high-dimensional space. The algorithm calculates probabilities based on the proximity to predefined category clusters, relying on Bayesian logic to predict data labels. However, as autonomous AI agents begin to reason over data, they face the risk of hallucinating connections or producing unreliable results. To prevent this, organizations implement human-defined taxonomies as guardrails. These provide the machine-readable language that limits what an agent can reason over and act upon, ensuring alignment with industry standards. These taxonomies define the specific logical boundaries that autonomous systems require to produce reliable, interoperable results. The final phase of this evolution is the semantic web, a shift from isolated databases to a global web of data. This system moves away from localized, word-based searches in favor of semantic networks using globally unique uniform resource identifiers. This architecture uses the resource description framework to classify information into logical triples: a subject, a predicate, and an object. These allow software agents to automatically crawl and relate information across disparate servers, creating a global layer of classification. This modern semantic network is a direct execution of Aristotle's fundamental logical propositions, now operating at internet scale. The trajectory of organization has moved from sorting physical cards to mapping unstructured big data with large language models. Despite the shift from printed catalogs to infinite digital matrices, the underlying architecture remains the same. Classification is the defining mechanism by which humanity renders the universe understandable.